Okay, welcome back, everyone. Our minute is up. We need to transition from all the great slideware to the tactical. Yes, so Pipe, would you please help us walk through a lab, show us all the good stuff that we can do with, this ML thing that we talked about? Introduce yourself and let us have fun with all the tech. And you might be muted there, Pipe.
Here we go. So thank you, Wayne. Thanks everyone also for attending today. Thank you, Andrew, and the rest of the team, Sarita and Rangoli. I think every time I join one of these sessions, there's a lot of wealth of information to learn from. Even working at Google for little over 3 years today, I keep learning from all these sessions. So I hope you're also getting a chance to brush up on new content as well. We will be walking through a lab, but before that, I want to quickly introduce myself. My name is Pipe Martinez. I work closely with Wayne, with Andrew, and Rangoli and Sarita. I'm also a customer engineer and been at Google for about 3 years now. We're going to be doing one of the quick labs. I think you got a little bit familiar with Rangoli's lab on what the whole quick labs things looks like, and it creates a whole environment for you that you can tear it down after an hour of a limited set amount of time. So I think that comes very handy. I know some of you have been having a few troubles trying to get the credits or to use quick labs. Hopefully we found a solution by now. Please check on the chat and check with the moderators. They'll be able to help you or assist you. But in case that you still can't do them, don't worry. You can sit back, relax. The whole session today is being recorded, so you will be able to come back later at this and follow along. Okay. So with that, I guess we can get started. I hope everyone can see my screen by now. I've split the screen in two, so we can follow along the steps on Quick Labs on the left side of the screen, and then on the right side we can interact with the console. So I'm gonna go ahead and click the start button on the lab, so it spins up the whole environment for me. I'm gonna go and log in here, and while I do so, I'll briefly explain you what we're gonna be doing today in the lab, so we don't have to go read all the whole steps and actions to take. Okay, so basically, I want everyone today to take four things from today's lab. On the one hand, we're going to learn how to create a workbench environment, or also known as a notebook, right? So the job of most data scientists today, it generally starts and it also sometimes ends on a notebook. So this notebook or IDE environment is where you can start coding or rambling with the data, aggregate the data, do a lot of analysis, aggregations, feature engineering, which is another of the common tasks that machine learning and data scientist engineers do. So that's basically your IDE. So if you were a software engineer, you probably will have another IDE, and data scientists mostly they work on notebooks. So first thing, let's learn how to create a notebook. Secondly, we're going to show you briefly how normally a data scientist will create a machine learning model. We're not going to get into the details of the codes and the lines and what particular machine learning models have been picked, but we'll show you what generally the workflow is for a normal data scientist. And then we will compare that um, to how to actually train one of those models in the cloud versus training that model in your own local environment. So there's many multiple reasons why you want to do that, right? Like sometimes you're running on your laptop and you just don't have enough capacity to train a model, or it'll take like days to train one. So that's where the power of the cloud comes together. And then last but not least, we will look quickly into how to actually infer out of that model, how to run predictions once you've created that model and hosted that model in Google Cloud. Okay. With that, we're going to be working. So this particular example, it focuses on predicting what's the income category for a given person, and it bases that data, or the training data will come out of a public data set around the USA census, income census. Okay. But again, I don't want you to get too hung up on the details, but instead on the different tooling around a data scientist and machine learning um, role. So, Yeah, we've covered that. We'll be building a model that it'll be very simple. It'll pretty much predict whether, given certain information about a person, we estimate that they are earning more than $50,000 a year or less than that. So it's pretty simple. That's what I don't want you to get hung up on that. So the first thing that we need to do is to go ahead and create this workbench or this notebook environment. For that, I'm going to head over here in the console. So on the left sidebar, we're going to scroll down in the product section. We're going to go see the AI piece of it, where we have all the different artificial intelligence services in the Google Cloud Platform. And as you can see, there's a lot of them. So we heard, I think Sarita and Andrew talking about Vision AI, which is right over here. We have translation services, speech to text to speech. So it's really, there's really a plethora and a pretty like a broad wealth of services that will help you along here. Today we're going to be focusing on AI platform. Please bear in mind that we've re-ranted and added more services to our AI platform, and now we call it Vertex AI. But for the sake of this lab, just to follow along with the steps, we're going to be working on the AI platform. Okay, I'm going to click where it says Workbench right here. um, Sometimes you need to enable the whole service, so the AI platform service, to do certain stuff. So one thing we need to do first is to choose the project we're going to be working on, and this project is already created for you and is pre-populated here in Quick Labs when you create and start the lab. Okay. We're in this screen, the first thing we want to do is we want to create a notebook. Okay, so there are multiple ways of doing that, but we're going to do these from here, new notebook. And you can see there's a list of different pre-baked notebook environments or data scientist environments that can pre-bake for you. And they have all the required libraries installed for you. So you don't really have to go and figure out what needs to be installed and where and when. And also it will streamline the startup process, the startup time for that particular notebook. We're going to be working with TensorFlow, so we'll create a TensorFlow environment. We're not going to be using GPUs to accelerate the training. You could do that if you wanted as well. So I'm going to click in here. I'm going to edit some of the defaults for these, and I think particularly the lab is asking us to create it on the US Central region. Sometimes if you try to create it in another region, Quick Labs has some guardrails in place that will prevent you from doing so. So if you fall in on, if you end up in any issues, try to make sure that you're following along the selections in here. And last but not least, we're going to change the machine type that we will be working with. So we'll specify that we will need 2 CPUs and 8 gigabytes of RAM, so our N1 standard machine. With that, I'm going to go ahead and create it. Now, this generally takes a few minutes, which, to be honest, it's nothing. If you use other platforms or environments, it could take up to 15 minutes to create a whole notebook for you. So that's one of the beauties of GCP and the platform and the underlying engineering behind the scenes, is that most of the machine startup times are pretty fast. This green check marking here, it's telling us that the VM has been provisioned already, and now what's taking place is the actual startup scripts are being run in the machine. So we'll give that a little bit of time. We'll go back and read up on what the next steps are that we have to take. Whenever this machine comes online, we'll see a button in there that will let us access that notebook and start working in there. For this particular lab, we're going to be redirected to use GitHub environment. So we'll get all the code from a GitHub project. So I've already opened that project here on another tab. I know this looks a little bit skinny and narrowed, but I'm going to scroll all the way up and we'll see what we're going to be doing. So this particular project, it has all the steps to be performed. So we're not going to be doing feature engineering ourselves. We're not going to be actually doing all the job of a data scientist. Instead, we're going to be doing or leveraging the tooling that the data scientists will be doing, right? To train the models, to inference from the model, to deploy the model, etc. Okay. And the reason we're not doing that is because that's very unique to your particular need or use case. You might be using different frameworks. In this case, we're going to be using TensorFlow or Keras, but you could be using PySpark, scikit-learning. There's a lot of different options to do things, and the good thing is that you can use all of them in the GCP platform and using notebooks, so you don't have to be using TensorFlow only. So while that takes place, the first thing that we'll be performing is we're going to be copying data that is already exposed in what we call a Google Cloud Storage bucket. I think Sarita talked about cloud storage buckets in during her presentation. So we're going to go ahead and open this Jupyter lab in here. For those that are not familiar, so this is a common, like Jupyter is a common notebook platform. I think there's Zeppelin as well, there's others, but Jupyter is, I would say, somewhat of an industry standard today, or is one of the widely most used notebook environments for data scientists. I think the first steps that we need to perform are to actually clone the code from GitHub. And for that, we're going to open the terminal. We're going to skip that. So we're going to open the terminal. So we're right now working on a VM in the cloud that has all these things built in into it, and we're kind of remotely connecting into that VM. So as I said, the first step is going to be to clone the repository from here. And this will download all the data files, all the files in that GitHub repository in our local environment in here. So once we're done with that, we're gonna go down to a specific folder that has these steps for these labs. Just don't get lost in the GitHub environment because there actually are multiple samples in there. So there's a lot of code. I'll show you specifically where we want to get into. Okay. So while we give that time, so here we go. So this is the actual path that we need to get into: training data analysts, self-paced labs, AI platform, quick start. Okay, so we can see here how already a new folder has been created as the GitHub code is being fetched. We'll click in self-paced labs, and then last we're going to go to the AI platform quick start. And here we have an IPYNB, which is pretty much like a Jupyter notebook file. We're going to open this up. And here we have the same code that we were following the GitHub repo. So no need to refer to that repo anymore. Now, since some of the steps that we'll take will actually take a few minutes, because some of them will train the model, and that can take a few minutes. We'll be trying to skip ahead in some sections. So the first things that we're going to do in here, this is all using Python, by the way. We're going to import like the OS library in Python, but the first thing we really have to do is to download the data that is living right now in this public data set that everyone has access to. Once the data has been downloaded, and by the way, if you've never used a Jupyter notebook, so you have these snippets of text follow or concatenated with snippets of code. So these actual pieces in here are executable code that by simply running shift command or shift return, sorry, they will execute. Or you could also come here and click the apply button, or in the run you can just run a specific cell. So that might come very handy as you start to get familiar with Jupyter notebooks. Okay, so it looks like the data has been downloaded. We see how a folder in here has been created. I'm going to go back, and we have a few different files. I think they're all CSV files. So we have the data, the test data, training data. Let's see if I can maybe the test data as well. So I'm going to go back one level. We're going to create some environment variables for training the data. So it's basically saving the path to these data in these environment variables. And we're going to quickly take a sneak peek of what these adult data CSV file looks like. We see it's a CSV that has probably what's an age, maybe what role or where he works, zip code, etc. So as we start going, the first step that we have to take is to create or run a local training job. As I said, all the data scientist work has been done in here. So we have already the files that will help us with all feature engineering, with selecting the model we're going to be training, evaluating that model, etc. So first thing that we do in here is we create a util.py file that, as the name suggests, It has a set of different functions that will help you to load the data from a CSV file. We'll do some feature engineering of in that data if needed. So again, we do not need to get into all the details of what work has been done in here. The second file is the file that has the model. So yeah, so this model.py file, it has the functions and all the architecture of the model that we'll be using. Now, the third file that we have in here is the task file, task.py, and here is where all the magic will happen. So the training, so all the steps that tell TensorFlow and Keras to build the machine learning model take place. Now, we've created the files. We can see how in the trainer folder, there's like these three files that we created. So that's all that TensorFlow will need in order to create a model. We downloaded the data, we created the file. Now, the next step will be to actually kick off this model. And this model will be trained locally in this VM. So this is what we call local training. All this work could also be easily done in your own laptop. So it doesn't have to be a notebook running in the cloud. It was just easier for me in here, but this could be your dev environment somewhat as a data scientist. So we'll quickly look at the parameters that we're using here. You can see we're using the gcloud command, and this is the command line for Google Cloud. So we're using the gcloud command line to tell AI platform to train a model locally. And this is just all happening locally in this VM again. We're not actually telling for this model to run in the cloud. We're passing a few parameters. More specifically, we're telling it what's the module that we're going to be training. So in this case, the package path, it's pointing towards this folder that has all the necessary functions or in Python to build the model. We're telling them where we want this model to be written into, so a directory in which we want the output to be wrote into. We're specifying what is the training data and the evaluation data for that model, as well as some hyperparameter tuning, telling them how many steps we want it to run, how many eval steps we want them to run. So I'm gonna go ahead and kick that out. Kick that off. That will take generally takes a few minutes. Okay. So once that's done, then we're going to be able to see a folder in here that will have a whole machine learning model built out for us. And if you want to relay this to what Andrew was telling us, so this is pretty much going to have the whole mathematical model that will help you given a certain amount of input. We'll run it through a function and we'll generate an inference or an output of that. So it'll be a mathematical model that is being built and is being trained behind the scenes. Now, this is a somewhat of a small data set that we're using to train the data into. But just bear in mind that for larger data sets with billions of rows, maybe terabytes of data, this can take up to days to train these locally. And that's kind of one of the reasons why generally you want to do most of the big training in the cloud. You might have some smaller data sets that you use to kind of develop locally and play around with. That's something that your machine can take care of. But in the long term, you want to train these models in the cloud so you can leverage the distributed capacity of the cloud. Okay. Now, we'll kind of skip ahead while the model is building. We'll come back to it later. But then the next steps are pretty much showing you how to run predictions on the model that we built. Okay, so it has a snippet of Python code that would load the data, and then it will create a data set for prediction. We're going to look at that data set. So actually, I believe that we can probably get this started. So once these prediction data sets have been built, okay, here we go. Here we go. I think the model has been built now. We see an output folder, and it has all the different files that the Keras and TensorFlow need for the model to train once it has been trained. So if we actually run these, we'll see what files have been created, right? So essentially, you with these files on its own, you could start running the predictions, and this is what we're going to do next. So you can see in this step right here how we've run this function. We're going to print out what we've this evaluation data set that we've created, and we can see that it has age column, work class, education number. Now, if you compare the data that we have in here to the data that we looked into at the beginning of this notebook. Let me scroll back real quick in here. We saw how data like age was an actual number, the zip code was a number, maybe a bachelor's or the degree that was a number, the marital status was also a name. So all and but when we come in here, we'll see how these are actually numbers, weird numbers that it's hard to understand. So this is generally what we call, it's part of the feature engineering process, in which we try to normalize the data and make it more machine readable. So the age has been normalized, and now the numbers are, they do look different. You see how all the categorical variables such as work class, they're no longer a text, but instead they have been transformed into a class in which maybe three relates to divorced, maybe number two will relate to single, right? And the same for the sorry, for that was for marital status. For work class, same thing, occupation. So you see how these are all numbers. This is going back to algebra, mathematical, right? How machine learning works behind the scenes. It pretty much takes numbers as inputs and tries to train a model based on numbers. Okay. So with that data, the next step is to actually go ahead and try to run a prediction, right? So I'm going to quickly go through these steps. We're parsing the data we have evolved and putting it in a input friendly fashion. So basically a CSV file. Well, this is a JSON file, comma delimited file, and that is what AI platform will take as an input for prediction. And I know if you're not a data scientist, this might all sound like Mandarin or like a foreign language to you. Again, this is mostly data scientist work. There's a bit of a learning curve, but there's a lot of different training that we offer as well on the topic, in free training in Coursera as well. So I highly encourage people to go start looking at our machine learning paths. Okay. So what we've done here in this step is pretty much ask AI platform to run a prediction locally. Okay. We see the output is also hard to read, so it's hard to understand what this actually means. So I'll give you the gist of it, but you can read it up in here. So any number that comes out that is between 0 and 0.5, it pretty much tells you that this particular person, or the data that was provided about that person, would relate or would be estimated to be a person that earns less or $50,000 a year or less, versus if a number or a prediction number came out to be higher than zero point 0.5 and lower than 1, that relates or infers or tells you that that particular person might be earning more than $50,000. It's all about inference, right? Model might be right or might be wrong, but you're building a model that will kind of help you predict these outcomes. Now, I hope that that was somewhat clear. I'm sorry if I rushed through it, but now I want to get to the juicier piece of it. So we've done all this locally. Again, this is the journey that generally a data scientist will take in their own local environment, in their own laptop, or even in a notebook in the cloud. But again, as things start to get bigger, more robust, and require a lot more compute, it's a is recommended to run most of these training models in the cloud, not only to leverage the processing of the cloud, the power and the scale of the cloud, but also because it comes with a lot of added benefits about model tracking, explainable AI, and we can talk about that later, maybe while we wait for this model to train in the cloud. So, what are we going to do here now? We're going to run the same steps that we did before, but now we're going to tell GCP or AI platform in GCP to build the model. So we'll be pretty much hands off in here. The first thing we're going to do is we're going to read up what project we're running into. I think we know the project already. Here's the project. I'm going to quickly copy this in here and change it. Oops, sorry about that. Where were we? Here we go. There we go. Gonna run these steps. So where this is pretty much defining the variables. Okay. So we're saying what the project is, and then define a few environment variables. First step we really want to do is to upload this data into the cloud. What do I mean? So the data is right now living in this folder that we downloaded. So the data folder in here. Now we want this data to be uploaded to cloud storage, which is an object storage solution in cloud in GCP. And you most of the times we'll use that as a staging zone, right? Where you're gonna drop in files in there. Your data prep, as we saw Rangoli doing, data prep will be reading from cloud storage. It could be writing into cloud storage. So you can think of it as like it's object storage in the cloud. By running this particular snippet of code, what we're doing is we're creating a bucket. So this is the gsutil command in here from gcloud. It's the MB stands for make bucket. So we're telling it to create a bucket in a given region that we specified, which is US Central 1, and then we're giving it the bucket name. Now, after that, we're going to go ahead and upload all that data to that bucket. We'll go back and look at that data in a minute. Next step, we're creating environment variables to refer to this particular bucket, the data within this particular bucket, so the training data and the evaluation data. And we're also uploading our test.json file that we created, if you recall, a few steps above when we were running the prediction. Last but not least, we're going to be creating another environment variable for this test data. So the reason we're creating environment variables is to keep it cleaner when we run the commands for training, so we don't have a lengthy command in there. Now, if we've done everything right, by now we should be able to come back here in Quick Labs and check the progress. So the first thing we're going to say is, have we created our cloud storage bucket? So if I check in here, I should see like a green mark telling us that we did create it. That's great. The second checkpoint will be, have we uploaded the data files into this bucket? And if I click in here, we'll see another green mark. So meaning that's pretty much accomplished in the step that we run here, above number 18. Now, as we move along, this is where things start to get more interesting. So you're going to be training the model on the cloud. So instead of training the model locally, we will be doing that now in the cloud. Now, bear in mind that all the model and all the specifications of the model or are the files that we already created, right? So all these Python files that we created at the beginning, that the data scientist or the machine learning engineer has been working a few days or weeks on building. Now, what are we going to be doing in here now? We're going to give this job an ID so we can refer to it later. We're going to specify where we want the output to be written into. So we're going to write that into the bucket that we created. It's a common best practice to write that using the same job ID. So you can train the model multiple times, either using different data that you might have, or maybe modifying the data and doing different stuff. So you want to be able to map back whatever job you run and the model that came out as an output of that to the data that you use as an input. So after that, I'm going to kick this off, so because it takes some time at the beginning, and while we talk about the different parameters. So now we're going to call AI platform again, as we did in the past, to train locally, but now with the difference that this is going to be submitted to a jobs to be trained in the cloud. Okay, so you can see the command is pretty similar, but instead of training the model locally, it'll be trained in the cloud. We're giving it an ID. We're telling them where we want the model to be written into, what Terraform version we're using, what Python version we're using. We're specifying where our actual code is located, so in a task file in the trainer folder, what region we want this to run into, what are the training files that we're going to give it, what are the evaluation files we're going to give it. We're going to specify the very same hyperparameters, such as 1,000 train steps and 100 evaluation steps. And last but not least, we're going to give the verbosity flag here to debug, so we can get more details on what's going on behind the scenes. Now, if we want to know what's going on behind the scenes, and as I said, this might take the next few steps. I think the last one, now those will take a few minutes, so I'll try to get faster in there so we can explain later. Now, what we've done so far is we created a model. Now, we haven't submitted the training job just yet. We've told AI platform to create that model. So if we come back in here to the AI platform section, and we go here, AI platform, and we go to models or jobs, jobs. we'll see how a whole job has been kicked off, and this is pretty much training behind the scenes. So all the interactions we've done with the console so far have executed something in the cloud, right? So this is how we know that the model has been trained in the cloud. It's been running for about a minute and 30 seconds so far, and it might take about 5 or 6 minutes. Okay. The next things that we might want to do is just to see to check the logs of that model if you wanted as well, right? So we could either do it from the console in here, or we could go back and work on that from the UI. So you can come here and click on view logs, and we can see all the different steps and actions that uh, AI platform training is taking on our behalf. So the screen is a little bit small. I hope everyone can see the screen, but this is how you can monitor how the model execution is going so far. Now, as I said, that will take a few minutes to finish. Once that's done, we should be able to come back here and see if the model has finished training. Okay, and we can check our progress. So while we do that, why don't we take a quick look at the console? So we'll give this a 3 4 more minutes that it generally takes. We'll go back to the console and talk about some of the other things that the AI platform supports and provide. Okay, I'm gonna go open first cloud storage to show you the actions that we took, what impact they had. So well, these runs, so we'll see how, here we go. We'll see how in cloud storage we have the bucket. It has the data we've been created. It already has the model we're kicking off as well with all the data in there. So, and then on the AI platform side, we'll see how the job is still spinning and running. Now, the last step to perform would be, sorry, yeah, the last step to performing here will be to create a model. So right now we're training that model, but the other thing that we can do in AI platform, and this is the fourth thing that I wanted you to take away, is the ability to run predictions online. So host this model in the cloud so that GCP can you can run inference out of GCP directly. So meaning that you do not have to run this locally. You call an API, you give it the input parameters like what's the age of the person, what's the marital status, the working class, etc., and then you get right away a response or a prediction out of that model without you having to deploy that in a web server or having to manually do that. Now, since this is probably is going to take a few more minutes, I'll try to go ahead and start creating that model, which I think it's something we can do separately. So what we told in here in this section is to create a model. We've named that model census. We told them where we want that to be to live. And then the last step we'll have to perform, and this probably will take 10 more minutes. So I don't think we're going to have enough time to go through this. But this last step in here is once the training has finished, we will be able to deploy these and run inference out of that one. So we're gonna go quickly check what's the status of the model. We'll see it's still running. Let me refresh this in here. It's been running for about 5 minutes. We might be coming to finish. Now, with this step in here, we've created a model, but we have not deployed any version of that model. So far, all Vertex has is metadata about a model. So we told them that we want to have a model. So if I come in here in the UI and I click in the model section, I'll see how the census model has been created, but there's no versions associated with it. We can create a version directly from here, and we could upload or specify all the parameters and upload the model into cloud storage and have it created from there. But what we really want to do is for the census to finish, so for the model training to finish, and then directly create the model from the Jupyter notebook. Okay. And I know this generally takes some time, and that's how behind the scenes how Google is working. So it's creating machine instances of virtual machines. It's running all the training on that model. So for smaller models, sometimes it's convenient to run them locally. But as you start to scale and have more data and need to build models, larger models, that's when the power of the cloud will and the distributed cloud will start to make sense. So we'll see. We'll give this a few more minutes. Here we go. So the model has been created. Um, We could check our progress in here and we get a green mark. And then the last step to perform is to deploy this model. Now, unfortunately, just to make sure that we have enough time for the Q&A, okay, I think we need to update some of the variables in here, but we won't have enough time to run through the deployment of the model, mostly because of the fact that we want to spend more time in the Q&A sections. We want to give you more time on that. So I guess let me quickly check. I think we might framework identify. Here you go. Fail precondition framework and now into from model path. So it looks like the model path that we gave it, maybe we didn't create one of the environment variables in the top. So okay, this is job ID. So here's where we want to give the job ID. Let me quickly run this, and with that we will wrap it up. So this one we did it. So here, if we run this step in here, this will take again 5 minutes, maybe 10 or 7 minutes. But what's doing behind the scenes? This only takes this time the first time that you run it. Subsequent deployments of models, they run on updates, so they will take a few seconds only. But this one particularly, what's doing behind the scenes is in the model section. You'll be able to see how a new version of that model is being deployed. And then after that, directly from the UI or from the console, you can come here and run evaluations or predictions by giving certain inputs, or you can see the version that has been deployed. Now, with that, we can check this one last. And this one, we're not going to be able to check it because the model is being deployed. So with that, I think we can probably wrap up the lab because it's going to take another 7 minutes. So I hope this was helpful. Again, there's a lot to machine learning. There's a lot of things, and probably Google Cloud Platform is one of the most advanced platforms to run and train your models and run pipelines and do even DevOps or machine learning operations or MLOps in the cloud. We can talk about that during the Q&A section. But I guess with that, I'm going to pass it back to Wayne so we can move on into the Q&A section. Wayne?
All right, thank you, Pipe. And I am really sorry that this ML algorithm didn't go faster so you could show all the goodness that it was going to produce at the end. But we will definitely consider, and we'll talk about some of the things around this here in a second. So I would love, for the sake of time, because we do want to make sure we end on time, to bring all of our panelists back together. And that way we can just really just talk as a team. So we're going to take just a second or two to do that, to bring Pipe back, to bring Sarita, Rangoli, and Andrew. And then, as I promised, we have a lot of questions that are going to be coming their way. So give us 30 seconds or so, and then we'll bring right back with the entire team.